Good morning, welcome to
Family Math number 37.
Math number 37. I'm going to try to squeeze in here. Alright, so on Friday night, we were at a talk, and the woman giving the talk said if you had the sun and the earth, you could fit 109 earths across the sun. Yeah, that was pretty neat to learn about, right?
Yep.
And then she said that meant you could fit about 1 million Earths in the sun. And I thought we'd talk about how she figured that out so fast. Okay, does that sound like a fun thing to talk about?
Yep.
Normally in family math we do things that we have lying around the house, but do we have the Earth lying around the house?
No.
Do we have the sun lying around the house?
No.
Okay, well, but maybe we can still talk about it anyway. Maybe someone watching will have the Earth lying around their house. So, okay, so first of all, we need to talk about volume. That's how you figure out how many things can fit inside of something else, right?
Yeah.
Okay, so the easiest thing to talk about for volume is like a box. Okay, so if we have a box, it's a pretty good drawing of a box, isn't it? You see that? You see that box?
Mm-hmm.
So we have something, the length, that I'll call L, the width, that I'll call W, and the height, that I'll call H. And the volume, which I'll call V, is length times width times height. So for example, if we have a Duplo block, you see the Duplo block?
Yep.
And then we have a box that we've made out of Duplo blocks. To figure out how many Duplo blocks we used, one thing we could do would just be take it all apart and count the blocks.
Yeah.
Or we could say, how many Duplo blocks is this long? Can you count them for me real quick?
1, 2, 3, 4, 5, 6.
6 times how many wide is it?
1, 2, 3.
And how tall is it?
Oh, it's too tall.
Too tall. And does anybody know what 6 times 3 times 2 is?
36.
36. So we use 36 Duplo blocks to make this. Now, for boxes like this, it's actually pretty easy. But for spheres, does anybody know how to get the volume of a sphere?
No.
No? No? Okay. Well, I am just going to tell you that the volume of a sphere, are you ready for this crazy formula? This might be the craziest formula you've ever seen. You ready?
Mm-hmm.
You want to sit down, or do you think you can stand up to see it?
I think I can say that.
Okay, the volume is 4/3 times pi times the radius cubed. Whoa!
Whoa.
Whoa! How did they figure that out? I don't know. Well, maybe one day we'll learn about this. But, so, if you want to figure out how many Earth volumes fit inside the sphere, you would take the big radius, the big one, the sun, which is 4/3 times pi times big radius cubed over 4/3 divided by the Earth, 4/3 times pi times little radius cubed, and everything cancels. We haven't talked about fractions, but you understand this, right?
Yeah.
When we talk about fractions, this will make more sense. So all we get is the big radius cubed divided by the little radius cubed, and they told us that the big radius was 109 times the little radius, right? That's what it meant, that 109 fit across. Okay, so this is, actually, I'll go down here, sorry. 109 cubed times the little radius cubed over the little radius cubed. What cancels here? The little radius cubed, and we just have to figure out what 109 cubed is. But before we do that, there's an easy number really near to 109. What's an easy number near to 109?
100.
100. And what's 100 cubed?
It's 1 million.
1 million. So that's why she said it's about 1 million Earths fit inside the sun. Now, by the way, what she meant was that not that you could pack the sun with these little balls, because when you put like marbles in a bag, there's lots of space in between.
Yeah.
She meant like if you melted the Earth down into like a liquid and you poured it in, there'd be about 1 million Earths that could fill up the sun, like a bathtub. Okay? So, but 109 cubed is actually about 1.3 million. But people would just say it's about 1 million. Okay? Now, I have a little model here. I don't even know how well this is going to show up on camera. Actually, come face the camera so it's not up against a whiteboard. Here's a little 1-inch diameter styrofoam ball. And we're going to show you about how big the Earth is compared to the Sun. Because we need something that's 109 times longer, or 109 inches, which turns out to be about 9 feet. So we need something that's about a 9-foot sphere. Do we have any 9-foot spheres lying around?
I don't think so. Not in our house.
Not in our house. Shoot. It'd be like if we did, we could go crawl inside and run around like a gerbil ball. But I found something outside that's very close to a 9-foot sphere. You want to go see?
Yeah.
All right. Let's go to the outside. Okay, here we are outside at our Snowball hydrangea bush, which happens to be very close to a 9-foot diameter sphere. You can see I can reach about 8 foot tall, so it's 8 feet tall. So it's about 9 feet, and it's about 9 feet wide. Now hold up the Earth. There's the size of the Earth. Bring it over here real close to the sun. Whoa! Whoa! And so there's the size of the Earth compared to the size of the sun. And then here we found this pumpkin that would be about the size of Jupiter. So bring the Earth over to Jupiter here. Okay, so there's the size of the Earth compared to the size of Jupiter. And then one last thing. Do you know how far away, if we kept everything this same size, do you know how far away the Earth would be from this 9-foot sphere?
No.
About 1,000 feet, so about 3 football fields, and counting the end zones. So I can't even show you that because it would be like so far over there you wouldn't even be able to see anybody. Pretty neat, right?
Yep.
Okay, so we have the Earth, hold it up. We have Jupiter, hold it up. And we have, this is how big the sun would be. How cool is that? And we even have a little secret space monster running around. All right, good job, guys. Good job.